One thing I'd encourage you to look at is the 2 free ebooks we have at developers.redhat.com. So a lot of the content you'll see here today is also in written form and available to you. In this case, the Java Microservices book written by Christian Posta is very popular. It includes things like Drop Wizard, Spring Boot, and Wildfly Swarm to kind of get you started from a Java microservices perspective. And we also have the Vertex book, specifically the reactive microservices, where you can see the reactive programming model and building reactive systems, specifically microservices systems with Vertex. So 2 great resources for you to dive in right there. But we're going to keep moving along. Now let's start with this definition. This is the definition provided by James Lewis and Martin Fowler, and you can find it out there on the public internet, but it's specifically focused on the concept that microservices is an architectural style. Now style is a very key word here. Style means that, like all styles, they will tend to fade over time. That doesn't mean this one specifically will, but it is something that's kind of hot and nouveau and cool right now. And you should just factor that into your decision making as it relates to adopting this particular type of architectural style. Another thing that's super important is the concept of a suite of small services. The idea is you don't have a single code base, you have many code bases, otherwise known as microservices, and many independent teams managing those independent code bases. That's super critical also. Every one of these runs in its own process. That's its own operating system process. It's the easiest way to think of it. When you do a ps-ef, you should be able to see it. They're built with lightweight mechanisms. They communicate with things like HTTP as an example. That's a fairly common paradigm. You can use other invocation mechanisms, whether it be AMQP or MQTT or whatever you might want to use, UDP, TCP, but most people use HTTP as an example. They're typically designed around business capabilities. They're definitely independently deployable. That's rule number 1 in my book. And you also want to think of it from a fully automated perspective. So this definition actually holds very true to this day. It's been out there for a couple of years now, and I think it's appropriate that we actually talk about it briefly. But let's go ahead and keep moving along here. Now, I know microservices is super, super hot. The reason you're watching today is because you've heard of it too, and you're really particularly worried about it from a should we be doing it standpoint. Well, everybody's talking about it, and in theory, everybody's doing it. When I actually go out and speak to large groups of developers, and I ask for a show of hands in my microservices presentation, how many people are already doing microservices? About 80 to 90% of the hands go up. Everyone's doing it already. That's how hot and how hyped this thing is. But do notice that if you look at the Gartner hype cycle, it will eventually go through its trough of disillusionment, and it already has started that process at this point. Now, I know as a developer, you're probably thinking, hey, I gotta be a Silicon Valley unicorn too. Just like my pink unicorn with the rainbow mane here. That's specifically the GitHub unicorn. But we know everybody wants to be a microservices developer. It is that hot a topic. And in this presentation, throughout all this content, you will actually see some of the key characteristics that you'll have to apply to your talent set and your application architecture to determine if you're ready for microservices or not. Now, microservices is fundamentally about agility. Now, I know a lot of people out there are thinking, well, I want to do microservices because I'm tired of using vendor X's big old monolithic Java application server, and I'm tired of being stuck on Java 6 or Java 7. I'd like to move to Java 8 as an example. We hear this all the time, and it is a common concern. And you probably think, oh, if I just use Spring Boot, I can break with that old architecture and actually do some microservices. So we see a lot of people focusing on that concept of a certain technology and adopting a particular paradigm or something. But really, microservices is fundamentally about agility. And agility breeds speed. I actually used to coach soccer for many, many years. I coached soccer or football for a lot of people if you're international. I coached it for about 14 years, and one of the things we learned as we were building elite soccer players at this point was if you give them greater agility, it actually creates greater speed for the player. Their ability to cut, turn, change direction, move where the ball moves is fundamentally impacted by their agility, more so than their straight sprinting speed. So we're going to focus on the agility part of it because that is where you'll have your biggest win. Okay? So agility is number 1. One way you get greater agility, though, is by breaking this 3-month deployment cycle. Now, I'm using a 3-month deployment cycle because that is the primary metric to know how fast your organization is delivering value to the business itself. Now, 3 months is actually pretty fast. You might be thinking, our organization is more like 5 months, or our organization is more like 9 months. I've even seen some organizations who only deploy to production every 2 years. So That's relatively slow, and that's time to business value. Think of it like that. Your code offers no value to the actual business until it lands in production. And if it only lands there every 3 months, that's the only time you're offering value is once every 3 months, 4 times a year. So you want to actually shorten this cycle, this deployment cycle, shrink it down. And you can do that with numerous techniques. We'll talk about those briefly. One, you need to reorg to DevOps. If you're still fundamentally in the mode of where the developer throws it over the wall to the operations team and basically runs away from their software, and hopefully the operations folks can actually make that mess run, right? And they're responsible for it, that's a fundamental problem, and it's a part of your culture that you'll have to change as you go forward. So keep that in mind, that the developers have to also be part of the ownership of the actual software package. There's a lot to be said in the DevOps category, and we don't have time for it today. We'll keep moving on, though. Now, elasticity is also very critical, and by elasticity in this case I mean infrastructure as code. This is where we use software-defined everything. So I should have an API that allows me to provision a new virtual machine at will right now, not waiting 3 weeks for a virtual machine, but doing it right when I need it, as an example. Getting that new container stood up right away is an example of that. Also, think about your automation. If you're still manually SSHing into servers and actually setting up different initd, systemd scripts and things of that nature, you have a problem. You got to fix that. You need to have that thing fully baked out as an immutable image, as a gold standard, if you will, whether it be the virtual machine or the container image itself, and ensure that you can actually recreate it at will. Right? Using a tool like, whether it be, Ansible is a good example. Ansible playbooks do that really well. You can also just script around Kubernetes or script around OpenShift to do the same thing. Also, CI/CD, right? Most people practice CI in some form or fashion. In other words, they use Jenkins or TeamCity or another product like it. But in this case, we want to talk about the practice of CI, not the tool. So the practice of CI means that you can actually deploy from your trunk right to production right now, as an example. It's always ready to go. Your trunk is always ready to go. And more importantly, all developers on that project check in the trunk every day, as an example. So are those two rules part of the world you live in from a CI standpoint? Are you truly continuously integrating, or do you have feature branches that last for like 3 weeks at a time? So if you have a developer who's on a feature branch and only integrates once every 3 weeks, that's not continuous integration, that's every 3-week integration, as an example. All right, now, advanced deployment techniques are going to be super critical, and you're going to see examples of those as we go throughout the presentation, especially as we get later into it. But this is super critical if you want to go fast. How do you go fast without actually injuring yourself? You do that through like a blue-green deployment or a canary deployment, and we'll see those two things in action as an example. And if you do all these things, you can be like a super cool unicorn yourself. And of course, ready for microservices is the ultimate example here. Now, I'm not the only person who's talked about this, and it's actually Martin Fowler who actually talked about this at great length. And I do like to think of these key attributes as, and I really love this concept of you must be this tall, because I'm not a particularly tall fellow, and I was always that kid who didn't get on the roller coaster when he was smaller because I wasn't tall enough to get on the ride. That's kind of the point of this example here too, and that's the point Martin is trying to make. If you're not mature enough, and you're not big enough, and you're not skilled enough, you probably don't want to get on the microservices ride. That's the key thing to understand. But really think about these key tests here, right? How many days or weeks does it take to get a new VM provisioned? Do you have an expensive resource, like a software developer, waiting 3 weeks for a very inexpensive resource, like a VM? That sends a signal. It actually changes the culture of your organization. You got to think about that. How about your dev and ops, right? Who's on that pager? Who owns the actual application? The person who architected and created it and knows everything about it? Or the operations team who's never even seen it before and only has the binary to look at? Really, it ought to be the developer on the pager. They own the application, as an example. So these kinds of things are, just to think about as you get ready to enter into the microservices category, okay? Now, if you want to get started from a microservices standpoint, we have everything that I have running on the laptop today available to you for download. You can just go to developers.red.com and get started with downloading the container development kit. You'll see it in action as I get into the demonstrations. But these are just the steps that I use to get set up, as an example. So What I set up here on this laptop, you will also have available to you, and you can try some of these same techniques, same ideas, these rolling updates, these blue-green deployments, the concept of deploying a Node.js application or a Java-based application as a microservice, all that can be available to you also. Now, let's talk about some of this, all right? This is the water scrum fall. Maybe you've heard that before, maybe you haven't heard it before. But most of us at this point probably practice some form of agile sprint cycle. You know, we have a 2-week sprint cycle, a 3-week sprint cycle. We know our little bitty development team will actually go out and do our sprint, right? We even have our daily stand-up meeting. We have our burn down chart. We do all the agile kinds of things. The problem is with water scrum fall, on the front end of that, the water side of it, we might have a 6-month planning cycle. Basically, we've planned in advance for budget, and we've actually had a budgetary committee that has had to weigh in on what projects we're going to do this year. We've had an enterprise architecture team work on it. We've had a PMO design it, sign off on it, and of course, all that's part of the upfront that takes months in many cases before we can even start doing our development. You also have the back end of that. So on the other end, you have maybe a centralized QA team, an integration team. They're responsible for ensuring that the package delivered to production is exactly what they thought it should be, right? And they're responsible for all that sort of QA and manual work that is involved with that. There might be some form of IT ops who then sets it up on UAT, right? The user acceptance testing. And then, of course, the business gets back involved and looks at it downstream and goes, oh, yeah, that's kind of sort of what we meant when we said those requirements 6 months ago as an example. And then it goes to staging and production. And all this takes a long time, right? Now you've added months to the actual delivery of business value from an application standpoint, from a microservice standpoint. So this is a big cycle end to end, and that's why they call it water scrum fall. In this new world that we're going to be dealing with, though, we want to talk more about actual delivery at the end of each sprint cycle. So here, if we think of our monolithic system that we have today, it might be that it takes every 12 weeks to actually build it, have as much automated testing around it as possible, and then deliver it. Ideally, we'd do that in a 12-week window, and a lot of people do that in a 12-week window as an example. Now, if we bring in a little bit more agile thinking, though, we can think of the 12 weeks as 4 3-week sprints, or maybe 6 2-week sprints. It really depends on each organization, and I've seen different groups do different things, but you think in terms of breaking that up, and then now you have to think in terms of how do you make it faster. For instance, if I actually bring in tons of great automated testing instead of manual testing, I can shrink that original 12-week bucket right down to 6 weeks as an example, just through automation of simple things like testing. And it could just be great unit testing as well as a nice overview integration testing and other kinds of exploratory testing as an example, functional testing. You also have to think in terms of automating your continuous integration and build automation. There's still too many people out there doing manual builds of the software. And I'm not even talking about the people who still email their software back and forth to each other as their form of version control. Yes, I've run into a few of those, and hopefully you're not one of those here today. But for people who are using proper version control, getting their continuous integration correct, getting their build automation correct is still a challenge for them as an example. Now, if you start thinking in terms of really automating it and adopting things like either great VM technology, specifically where you can manage and orchestrate your virtual machines at scale, or in containers, right? So Linux containers are even lighter weight, easier to manage. And if you have something like, let's say, an OpenShift or Kubernetes to work with that, then it makes that automation even easier, and you can actually shrink that cycle time. Now your developer no longer waits for a week or 2 or 3 for that resource, right? They wait maybe 30 seconds to get that resource because that's how long it takes. The quota is assigned, they ask for it through an API, the quota is assigned and ensures that they don't ask for too much and they get the resource they need to start doing the development. Then you can start thinking in terms of continuous delivery pipeline, okay? So CI on continuous integration side, and continuous delivery means that we are now automating all the other tasks. We're not just doing automated builds where every check-in like we do with CI. We're now actually saying, let's actually take the package that went through some form of pull request ideally, did the automatic testing, did a code review, right? Went from the code review and then went into the actual rest of the pipeline from a staging, well, in this case, let's say it goes into the actual QA team, it goes into the staging environment, and potentially goes into production, but everything prior to production is really part of the continuous delivery pipeline. and continuous deployment is when you actually get to production. Also, start thinking in terms of zero downtime deployment strategies. One thing that's always a concern for people is when they actually are deploying really, really super fast, because I talk to people a lot, and they're like, well, if we deploy every 3 months, that's actually quite fine for us, that's fast. Because if we actually broke that speed barrier and started going even faster than that, we'd be worried that we'd be breaking things in production. Well, the concept of the blue-green deployment and the Canary deployment allow you to break things in production. You basically deploy to production, and if it's broken, you roll it right back instantaneously. Yeah, you might have some users that are impacted by that, and if you're clever about it, you can actually make sure those users are ones you know. For instance, like just your employees, or just a certain department within your organization sees the new change, and if they say, hey, something's not quite right, you can roll it right back very easily. You'll see that when we get to the demonstration. And over time, you're going to be building a high trust environment, right? If everybody has this great automation, great tooling, great scripting, great synergy between dev and ops and security and QA and all the appropriate parties associated with that overall package and delivery of that package, you will have a higher trust environment and you'll be able to deliver even as fast as 1 week increments. So we've seen organizations adopt many of these strategies and actually deliver from what was a 3-month deployment cycle now is a 1 week deployment cycle. Now there's something odd about this chart. You're probably thinking, wait a second, if we have 3-week sprints, how do we actually go faster to production than every 3 weeks, right? And in this case, I said we can get down to 1 week intervals. So you have to start thinking in terms of all your deliverables, right? It's not just the one and done software package that you've created, the one microservice, the one application you've created, but it's also all the patches over time. So it's not just the functional patches that the developers have to create, it's even patches at the operating system level, patches at the container level, virtual machine level, patches at the JVM level. Yes, the JVM has bugs and gotchas in it too. Maybe the framework that you're using, whether it be Struts or Spring or Hibernate, need a patch. You know, the JBoss Enterprise Application Platform, your web server, WebLogic, it doesn't really matter what it is. Your middleware also needs patches, and then your software needs patches. And all those could be part of those deliverables. So that would help you get faster than 3 weeks as an example too, because those can happen out of band. Now, there are organizations out there, and specifically this book. If you've not read this book, I encourage you to read it, that talk about doing 10 deploys a day. And that was true when this book was written. And the organization they wrote it about did 10 deploys a day, and they're notable for that. Now they're about 50 deploys per day. So things have evolved ever since then. So the concept of going even as slow as 1 week is still too slow for a lot of these organizations. So how do you actually move at the speed of, let's say, a Silicon Valley unicorn? How do you get to 10 deploys per day? Well, you have to take that component, that one monolithic system, and break it up into, let's say, 10 individual components with 10 individual teams that can deliver at their own pace, at their own interval, patching what they need to patch when it should be done, and actually deploying the functional aspects of that to their business, building new business capability with the pace the business needs them to match. So in this case, now we could go faster than once a week. We could actually go every day if we needed to with a new deployment into the production environment, just simply by breaking up that one big code base into smaller pieces. Now, we got more to discuss here. If you're familiar with a Java application, right, and I'm very much a Java traditional J2E, Java person from the old school Java universe. And so we had this concept of, you know, the operating system was always part of it. We had the Java virtual machine, of course, sitting on top of that operating system, whether that been on top of old school Solaris or AIX or even Windows, right? Now it's Linux. I can run my JVM on top of that. And inside that JVM, I packaged in my application server of some sort, right? We've had many of those throughout the years, and now it seems like there's essentially 3 big ones left in the universe. But I would package my application into an ear, right? The enterprise archive is one of the things we would use on a regular basis. And in my ear, I would pack in a war or 2 or more, and I'd pack some jars in there too. And some of the jars in the war and some of the jars in the ear, and of course, all that gets put into this one monolithic application. And here's the real problem with this architecture. everyone has to agree on the version of the operating system, the version of the Java virtual machine, the version of the app server, the configuration of all of these things, including the patch level, and then we all have to agree on all our third-party dependencies. We have to agree on what version of Spring we're going to use, what version of Hibernate we're going to use, and I've seen customers who've stuck 2 versions of Spring or Hibernate into their application by accident, and that didn't work out too well, I can tell you that. So you want to make sure that you actually do agree on all these dependencies. And you might have a relatively large team to actually babysit this overall monolithic system. Like in this case, I have 40 plus individuals, there's 18 programmers, 6 operations professionals, DBAs, you got to remember the DBAs, security and compliance people, business analysts. All these folks are part of that extended team. And this is the challenge right here. How long does it take to get 40 people to agree to anything? And that's one reason that this overall monolithic system actually moves so slow. Think about organizing the local Girl Scouts or Boy Scout troops. If you have to actually pick what snack to bring on game day for your little soccer team for your 5-year-old, it takes time to organize those people. Can you imagine organizing 40 different technical people to get something done? So this is why a deployment takes so long in many cases. Now, you might break up those teams into individual delivery teams that have their own individual product, their own individual component and capability, known as the microservice, and they actually are cross-functional teams, meaning they have all the skills they need to deliver their capability. They have operations professionals, developers, QA people, project managers, design people, whatever it takes to actually deliver their capability. And you can even see here, I have, some components look more complex than others, some teams are larger than others. All the original people are still here, but we've kind of broken them up and organized them differently, including this team in the lower right over here that specifically has 3 different microservices. So it's not like it's 1 team per microservice. It might be 1 team for 4 microservices, as an example, if that's what fits within that overall team structure. The phrase here, the 2 pizza team, you build it, you own it, is super critical. This actually came from Amazon as an example. The idea of 2 pizza is fairly straightforward, right? 2 American-sized pizzas, for those folks outside of America. I know this doesn't translate. You're thinking a pizza is this big. No, this is an American-sized pizza. It's the size of this table that I'm working with here. But you can actually have a 2 pizza team, meaning you got to feed the whole team on 2 pizzas. So let's call that 6 to 8 to 10 people or so. And then with that group of people, you actually have to deliver the product you're going to deliver it. And you own it, right? So that team, the delivery team, literally owns the product. If it goes down, they're on the pager. That includes all the developers and all the operations people associated with that team. They own it. So that's super critical. And this concept of accountability is one of the reasons these teams actually build better software faster. Accountability really matters. Now, here's some key principles and characteristics. We don't have time to go through them all today, but I'll just call out a couple of them for you. One is deployment independence. You have to be able to deploy each of these components completely independent of each other. That's a speed enabler, that's an agility enabler. Basically, as each component comes into the system, I can do that, rolling that out into production with 0 downtime to the rest of the system. So that's critical. We'll show you some examples of how we do that when we actually get into the Kubernetes and OpenShift demos. But that is an example where, from a microservices perspective, this is a key enabler of agility, a key enabler of speed, is knowing that when I do roll a change with team over here versus team over there, I have 0 impact to the rest of the organization, where you can just roll it to production with no problems. If you look at around number 2 here, organized around business capabilities. Typically, these folks are organized around a specific business unit or business capability, some aspect of the system that really matters to the business and really matters to the end users. You wouldn't necessarily put all this effort into some little utility component that no one really cares about. You got to really think about what is offering the best business value. What does it mean to offer that business value faster by getting new software components and new software capabilities to that business faster? Do think in terms of being API focused. We'll show you a little bit about APIs in this presentation, but be very API focused. You're married to your public API as a microservices developer. Each of your 2 pizza teams is now responsible for their API to the rest of the organization, who are all their customers. You have to think in terms of having these internal customers, and if you break your API, you break backward compatibility, that's shame on you as a microservices developer. That's something you cannot do. 2 bullets here, though, that are the deal breakers for so many organizations, number 6 and number 7. Decentralized governance. Each team, each two-pizza team is responsible for their microservice or microservices. They are responsible for building it with the technologies that matter to that specific capability. If they have to have Mongo because that's what they want and that's what fits their capabilities correctly, they will use it. They're not a one-size-fits-all like we've had in the past. It used to be that the enterprise architecture team would dictate from on high, look, we're all going to use this type of configured application server and database environment for our worst-case workloads. Well, a whole lot of workloads within an enterprise don't look like worst case. They actually are maybe small or medium, not always large. And so decentralized governance means that we can actually have teams responsible for their business capability, responsible for their delivery cycle, pick the technology that they want, and quickly put that out into production as an example. Also in decentralized data management, this is a major gotcha. So if you have a centralized database administration team, DBA team, like many people do, they won't even let you change your schema when you want to. If you're a developer, you know what I'm talking about. You're like, what? I can't even bribe this guy to change the schema. What am I going to do? Well, you have to decentralize that too, because that, of course, is a big problem when it comes to any kind of speed, any kind of agility. You want to be able to change the schema based on the business requirement that you see right now, and you decentralize that too. So, in the case of decentralized data management, your DBA will hunt you down and try to kill you. This is, I've seen this happen before. I'm kidding, of course, but it could be a problem. One tip I'd give you though. The DBA probably likes lightsabers also, so just keep that in the back of your mind. Take them to lunch. It's actually a good thing. But there's a great book on refactoring databases. I highly encourage you to read it. It's actually been out there a long time. You should actually check that out for understanding decentralized data management. But we also have a book that we've written and available to you at our public website. And so you can go to the Bitly link here, Mono to MicroDB, and actually get one written by Edson Yanaga on specifically strategies around how to deal with a monolithic database architecture. Well, that completes this topic, and we'll see you in the next video.